Do you wonder what it would be like to compete in Squid Game? Well, now you can find out with a JavaScript game you create yourself using Three.js. In this tutorial, Shuvo teaches you how to create a game from Squid Game with the 3D model.
Today I have a really exciting project for you guys. We are going to create the red light green light game from the series Squid Game. So if you haven't watched that series yet, the way this game works is you have this doll and you'll be given a specific amount of time, and in that time you have to move from this corner to this corner. But the catch is you can only move when she's not looking at you. If you try to move when she looks forward, you will be eliminated. So let's see that in action. So if I refresh, the game will start. The game has started and we can move. We can press arrow key to move. But if we try to move when she's looking forward, as you can see, it says we lost. So that's the rule. So let's try to win this game. And there we have won the game. So this is a really exciting project. I hope you're equally excited as I am. So make sure you like the video if you haven't already yet, and let's get started. Okay, to create this game we are going to be using Three.js. Three.js is a JavaScript 3D library. It uses WebGL to render graphics on the canvas. This is really powerful and easy to get started. So if you have no experience with Three.js, don't worry, because we'll be doing a lot of copy pasting from the documentation and I'll be going over the codes briefly. Okay, so let me close this window. And in my file explorer, as you can see, I have created a folder called Squid Game Tut. We'll be working on this folder. So let's open it up with VS Code. So click on open with VS Code. And now we're going to create the index.html file. So let's say index.html. And we're also going to create two folders. One is JS for the JavaScript file and one is CSS for the CSS file. So CSS, like so. Now in the CSS, let's create a style.css file. So let's say style.css, and in the JavaScript we need a main.js file, so new file main.js. So now let's link them in our HTML. First let's create the basic markup. Let me close the sidebar, Ctrl B to close the sidebar. Now exclamation mark tab, and it will create the basic boilerplate. Here let's link our style sheet, so let's say link, and the href will be css/style.css. Also link our JavaScript, so let's say script source equals to js/main.js, like so. And let me open it up with our live server. So click on open with live server, and it will be opened in localhost :5500. Okay, now we want to use Three.js in our project. So let's download the Three.js. So go to your Chrome and search for Three.js GitHub, and the first link will take you to the GitHub page of Three.js. So from here, click on the build button, and then click on the three.main.js. So .main basically means is the compressed version. It will load faster. Now click on the raw button. After that you can click Ctrl S to save it, and we want to save it in our project folder. So navigate to your project folder, go to the JavaScript folder, and we want to save it as three.main.js. So click on save. Okay, now if we open up our sidebar, and in the JavaScript folder we'll see we have the three.main.js. So let's link that file. So we're going to say script source equals to js/3.main.js, like so. Okay, now let's go to the Three.js documentation page, and here click on the documentation, and in the documentation page you will see we have a lot of codes that we can copy paste to get started. So let me copy all these codes, Ctrl C, and paste it, Ctrl V, like so. And let me close the sidebar again, and now if you go to our page, you'll see we have this black canvas. So let's see what's happening. So first we're creating a new scene by saying new 3.scene. So scene is basically what we see. To see it we need a camera. So in the second line we're creating a new camera by saying new 3.perspective camera. So we have many types of cameras. The perspective camera is most basic. So in the documentation, if you search for that, here is the perspective camera. As you can see, the perspective camera takes 4 arguments: the fob, the aspect, the near, and far. So this will make sense if you are into photography or camera. Otherwise you can leave this default. This will work just fine. Then we're creating a renderer. So the renderer is what is used to render all the graphics in our canvas. Then we're saying renderer.setSize, and passing window.innerWidth and window.innerHeight. So basically we're saying the renderer should be the size of our window. And then the renderer.dom element will give us the canvas, and we're appending that canvas to our document.body. So if we save it, we get this black canvas, but we have this little white space on top and left. So let's try to remove that in the CSS. So let's say target everything, and we're going to say the margin should be 0 and padding should be 0. So margin 0 and the padding can also be 0. If we save this, as you can see, now the white space is gone. Okay. Now let's try to add a shape in our scene. So let's go back to the documentation. So if you scroll down, actually if you go back, and then scroll down. As you can see, we have some more code, so let me copy all of them again. Control C, Control V. So first we're creating a box geometry. So in 3D world, the shapes are basically geometry. We have many types of geometry. We have box geometry, we have sphere geometry, we have cylinder geometry, we have polygon, etc. So the box is the basic geometry. We use box geometry to create cubes. So a geometry is made out of triangles or vertices. So we need to wrap our geometry with a material. So there are many type of material, but for now we just want to give it a color. So we're using the mesh basic materials, which is basically just a color. So we're specifying the color here, and then we're creating the mesh by combining the geometry and material here. And finally we have to add that cube to our scene. So we're saying scene.addCube. So if you now save it and open up that in browser, as you can see, we can see it. That is because every time we add something to our scene or update something, we have to call the renderer.render function, and we have to pass the scene and camera. So now if we save it, as you can see, now we can see the cubes. Now by saying camera.position.z equals to 5, we are basically specifying how far from the scene should be our camera. So if I were to make the number smaller, now the camera is more near to the scene, so it appears bigger. If we were to make it bigger, now the camera is more far, so this object appears to be smaller. So 5 is a good number, so let's leave it at 5. So every time we add a shape to our scene or update anything, we have to call the renderer.render function. But manually calling this can be a pain, which is why we use this block of code. So let me copy this, and then I will explain to you and paste it here. So first we are creating in the animate function. In the animate function, we are calling the renderer.render, and we are passing scene and camera. So let me just move it down. I like to put it in the very bottom, but it doesn't matter really. Okay, so what is happening in the request animation frame? We are passing the animate function. So what the request animation frame will do is call the animate function again and again. So if I were to console log something here, so if I say console.log hello world, and in the browser if I now open the console, you'll see hello world is being printed again and again. So basically the animate function will be called again and again. So now we don't have to manually call this function, call the renderer.render function here. Okay, now let's look at some animations. We can animate our cube. So let's try to animate our cube. So in the animate function, we can say something like cube.rotation cube.rotation.x plus equals to 0.01. So basically you keep increasing the rotation.x. So if we now save it, as you can see, our cube is now rotating in the x-axis. If we were to say rotation.y, it would rotate in the z-axis. If we were to say rotation.z, it would rotate in the z-axis. So the number basically is specifying how fast it should rotate. So if we were to make it 0.5, now it rotates faster. If we were to make it even smaller, now it is rotating very, very slowly. Okay, let me remove this code, and let me remove this. Actually, let's just comment this out for now. So we don't want the cube. Instead, what I want is the doll. So how we can create the doll? So in the Sketch Hub, I have found this 3D model of the doll. So this guy created it, and he is allowing us to use it for free. So you just have to create an account in SketchUp. After that, you can click on download 3D model and download the GLTF version. So click on download, and it will start downloading it. By the way, I will leave the link to this page in the video description, and I'll also leave the link to the finished code in the video description. So you'll be able to get everything from there. So if you decide to follow along and get stuck, you can refer to that code. Okay, let's wait for this to finish. Okay, the download is now complete. So we can right click and click on show in folder. And then I'm going to click on extract files, and let's say the folder name should be models. So let me rename this to models. So now this zip file has been extracted in this models folder. Here we have all the files. So let me click on the cut, and let's put it in our project folder. So my project is in www, and then inside the Squid Game tut, and I'm going to paste the folder here. So click on paste, and we can close the file explorer now and close this tab. And if we open up our sidebar again, you'll see we now have this models folder. Inside that we have the files for the 3D model. So now let's see how we can use the 3D model with Three.js. Okay, if I go to the documentation page again and search for GLTF, here you see the GLTF loader. Click on this. And this again gives us some example on how we can load a 3D model. So let me copy this line of code. So Control C and Control V. So first we're creating a new GLTF loader model. But to be able to use this GLTF loader, we have to first add it to our JavaScript. So again, go to the Three.js GitHub page. and then click on the examples, and then click on JavaScript folder. After that, go to the loaders, and here you will see the GLTF loader, so click on that, and again we can click on the raw button and press Ctrl S to save it. So we want to save it as GLTF loader.js, so save. As you can see, the GLTF loader has been added to our project, so let's link it in our JavaScript also, so let's in our HTML also. So let's say script source equals to, this time it will be js/gltf loader.js, like so. Now this line here would have worked if we were to install the GLTF loader with npm and imported it, but since we are using the regular script file, instead of just saying GLTF loader, we have to say 3.gltf loader. So simply say 3.gltf loader, and now this should work. Let's see what next we have to do. So after that, we have to call the loader.load function to load our 3D model. So let's do that. So we can say loader.load, and here we have to specify the path to our 3D model. So our 3D model file is in the models folder. After that, we have this scene.gltf. So let's say .. Since we are in the JavaScript folder, we have to go one folder up, then in the models folder. That's why we are saying .. models. And then we are going to say scene.gltf. Now this loader.load function will load this gltf, and once the loader is loaded, we will have a callback function executed. So this callback function. So let's create the body of this function here. So this callback function will receive the loaded gltf. So let's call it gltf, and then we can say scene.add/gltf.scene. And now if we save it and go to the project, as you can see, we can see nothing. Let's see why is that. Let's open up our console. So we don't have any error, but we still can see it. That is because currently in our scene we don't have any light. We need a light to be able to see objects or models. So let's add some light. So again, let's go to the documentation and search for light. In Three.js, again, we have various type of light, but the most basic light is the ambient light. So click on the ambient light, and let's copy this code again, and let's paste it. Let's paste it here, Ctrl V. So first we're creating a new ambient light, and then here we're specifying the color of our light. In CSS you may have said #404040, but in JavaScript we simply say 0x and then the code. So this is the code, and we can delete this comment, we don't need it. So now if we save this and go back, and as you can see, we have this doll. Okay, so let's change the light color to white. So let's say FFF, and now we can see the doll much clear, but the doll is very big, so let's scale it down. So we're gonna say gltf.scene.scale. So we're gonna call the scale function, and we're going to say .scale.set. We have to call the set function to set the scale. Okay, now since we are in a 3D world, we have 3 dimensions, and let's say we want to scale it to 0.4 on all dimensions. So let's say 0.4, 0.4, 0.4, like so. And now if we save it, it should be scale. So the spelling is SCALE. Now if we save it, as you can see, now the doll is a lot smaller. But one problem you will see is if I try to resize my screen, as you can see, the canvas does not resize. Okay, let's try to make this responsive. To make this responsive, we're going to use this block of code. So let's see what's happening. So first we're saying window.addEventListener. We're listening for the resize event, and we're calling this function. So whenever we resize our screen, so if we resize our screen, this function will be executed. And now let's see what we're doing in this function. So first we're saying camera.aspect equals to window.innerWidth divided by window.innerHeight. Since basically we have resized our screen, now the aspect ratio of screen has been changed. So now we are setting the aspect ratio to the new aspect ratio of our screen. And now since we have changed the aspect ratio, we have to call the update projection matrix on the camera. And finally we have to say render.setSize and set the size to the new window.innerWidth and window.innerHeight, or the current inner width and inner height of our window. So if we now save it, and now if we resize our window, as you can see, now the canvas also resizes. Okay, now let's bring the doll a bit down. So we can say gltf. So let's say gltf.scene.position.set, and here we can set the position in the X, Y and the Z axis. So we want to set the position in Z axis. So let's try 1. So if we say 1, it goes up, but we want it to come down. So instead we can use -1, and -1 should be good enough. Now let's try to change the background color. So to change the background color, we are going to say renderer. So we can, to do that we can say renderer.setClearColor. So set clear color, and here we have to say specify a color. So I have already chosen a color, let me use that. So the color I have chosen is B7C3F3. If we now save it, as you can see, now we have this bluish color, and the second argument is basically the opacity of the color. So we want 1 or full opacity. Okay, now instead of just loading the model like this, I want to create a new class called doll, so we can have some methods inside that class and easily call them. So let's create a class called doll. So we can say class doll. Inside that we're gonna have a constructor function, so we can say constructor, and let me cut all this code. So cut and paste it here, Control V. So if we now save this, the doll won't be visible in the screen anymore. That is because we have to create a new doll object. So let's try to create a new doll object. So let's say let doll equals to new doll. So now if we save it, now again we see this doll, and also I want to say this dot doll, it should be doll equals to gltf.scene. So like so. So now we can have some method in this class. So let's create a method called look back. So look back, this will make the doll look at the back side. So in this function we're gonna say doll.rotation.y to some value. So let's try 1. So now if we were to say doll.lookback, so doll.lookback, let me call the function and save it. And now if we look at our console, you'll see we have some error that is saying cannot read properties of undefined. So there is 2 reasons for that. So first reason is it takes some time for our model to load. So let's use a set timeout. So we can say set timeout, and let's say we are going to call this function. We are going to call the doll. So we are going to call the doll.lookback after, let's say, 1 second. So 1000 millisecond. If we save this, we'll see we again have some error. So it is saying cannot read properties of undefined. That is because we have used the regular function here. So if you use regular function, it creates its own context. So now inside the function we're saying this dot doll, we're saying this function dot doll. So we want this to point to this class. So we can't use a regular function. We're going to use the arrow function like so. Now if we save this, after 1 second, as you can see, the doll rotates. So let's try, doll should rotate to, let's say, -1, and now let's try -2. Okay, I think -3.15 will make the doll look backward. So now as you can see, if we call the look back function, the doll looks at backward. So we can also have a doll.lookForward function. So we can say look forward. We can say look forward. And actually let's call it backward, not back. So the look forward function will simply say this doll.rotation equals to 0. So now if we were to say doll.lookForward and call it, as you can see, the doll looks forward. And if we were to call doll.lookBackward, so look backward, the doll will look at the back side. But now as you can see, the doll rotates all on a sudden, but we want the doll to rotate slowly, gradually, or animate. So for that we are going to use an animation library called GSAP. So simply go to Google and search for GSAP. And this is the official site of GSAP. So GSAP is a really powerful animation library for JavaScript. So click on the get started here, and from here if we scroll down, as you can see, this gives us a CDN link. So I'm going to copy this link, Ctrl C, and paste it, Ctrl V. So again click Ctrl S to save it. So we want to save it at gsap.main.js. So save. Okay, now let's open up our sidebar again, and in the JavaScript folder, as you can see, now we have this gsap.main.js. So let's add it to our HTML also. So again we are going to say script source equals to, it will be js/gsap.main.js, like so. If we now save it, let's close this tab, we don't need it anymore, and let's close our sidebar by saying Ctrl B. Now in the main.js, so here instead of saying $.rotation.y equals to negative 3 point something, let me comment this line out, and here instead of this we are going to use the GSAP. So here we are going to say GSAP.to. The object we want is the this.doll.rotation, and the property we want to animate is the y. So we want to animate the rotation.y. So the rotation.y should go from 0 to negative 3.15 in 1 second. So that's what we're doing by saying GSAP. So if we now save it, as you can see, now the doll animates smoothly. So let's try to say 0.45. So in 450 milliseconds. Now it takes 450 milliseconds for the doll to rotate. So now let's do the same for the look forward function. So Ctrl C and paste it here. Here we want to animate from negative 3.15 to 0, like so. So now if we open up our console and call the doll.lookForward function, it looks forward, but it animates forward direction. If we were to call the look backward function, it looks backward, but it's rotating smoothly. So this is much better now. Okay, now let's create the track that the player have to cross. So let's create a function for that. So let's say function, and let's call it create track. So create track, and create track function will create the track. To create the track, we are going to use cubes. So we are going to use like 3 cubes. So to create cubes, we know we have to do all this. So let's create a utility function for that. So we're gonna say function create cube. So create cube, and in this function we can simply copy these codes. So Ctrl X and Ctrl V. Let me uncomment this and fix the indentation like so. Okay, now let's try to call this create cube function in our create track function. So let's call that function here like so, and let's call the create track function now. So create track. If we now call the function and save it, as you can see, now we have this cube. Okay, let me comment out the code for the doll for now. And now if we save it, as you can see, we have this cube, but we don't want the cube to be this size. We want to specify the size. So let's see how we can do that. So let's again go to the box geometry. So we can say box geometry. So as you can see, when creating the geometry, we can pass arguments. So we can pass the width, the height, and the depth of our cube. So let's do that. So in the create cube function, we're gonna receive argument called size, and when creating the box geometry, we are going to pass the size.height. We are going to pass the size.w for width, size.h for height, and size.d for the depth. Okay, now where we are calling the create cube function, let's pass the size. So we're going to say the width should be let's say 0.2, so it will be a skinny cube, and the height can be let's say 1.5, and the depth can be 1. So let's say d equals to 1. So now if we save this, this is how our cube looks like. But now we want one cube to be on this side and one cube on this side. So the function will also take a position x. So let's say position x. So, and inside the function we are going to say cube.position.x equals to position x. So now in the function, if we were to pass some position, so let's say the position x can be let's say 3. Now it is in this side. If we were to say negative 3, it will be on this side. Okay, let's create some global variables. So I'm going to create global variables here. So let's add a comment here specifying that we're creating global variables here. So let's say global variables, and we are going to have one global variable for start position. So here let's say we are going to have a variable called const start underscore pos underscore position, and let's say the start position will be 3 and the end position will be negative 3, or we can say negative start pos for negative 3, like so. Actually this should be end position. So let's say end underscore position, like so. So now where we're calling the start create cube function, we can pass the start position, and if we save it, we got a cube on this side, and we can also call this function again. This time we're gonna pass the position x as in position. Now we have one cube here, but now the cube is kind of rotated. So let's fix that. So let's say our create cube function will also take argument called rot x for rotation x, and by default it will be 0, like so. So now inside the body we can also say cube.rotation.x equals to rotx, like so. So let's try to rotate it. So let's try to rotate our cube. So let's say the first cube's rotation should be, let's try 0.4. Oops. Okay, so looks like the cube is being rotated in the wrong axis. So let's fix that. So let's call it rot y. And we want to rotate the y. And we want to say rotation.y equals to rot y. Like so. So saying 0.4 is making it even worse. So let's say negative 0.4. Now it's looking much better. Let's try 0.3. Let's try 0.35 actually. And yeah, 0.35 should be good enough. So and for the second cube, let's copy this, and this time it will be positive 0.35, like so. Control V. And for this cube, the position x will be 0, so it will be in the middle. So now we have this cube here. So now we have this cube in the middle. Let's also say rotation should be 0. And for this one, let's say the width will be starting position times 2. So if we do this, we will have a cube that spans from this side to this side. So let's give it a different color. Okay, so let's say our createCube function will also take a color as its argument. So let's say color, and the default color will be, let's say 0x and the hexadecimal value. So the color I want is FBC851. So now here, instead of saying color equals to hashtag this color code, we're gonna say this will be the color that we pass in the while calling the function. So color. If I now save it, as you can see, now our cube is this orange color. Okay, the cube is on top of other cubes. So in our createCube function, now we are also going to return the created cube. So we are going to say return cube, like so. Okay, so this is our biggest cube, this one. So let me just put it on top of other two. And now since we are returning the cube, we can say this dot position.z equals to, and let's say the position.z will be -1. So if we now save it, this is how it looks. Okay, instead of saying 0.1, let's try, instead of saying -1, let's try -0.8. And yeah, -0.8 works perfect. And also for this one, let's change the color. So let's pass a color here. So the color I have chosen is E5A716. So this is basically a darker orange color, like so. So now let's uncomment the new doll function here, and it looks like the doll is getting overlapped with the cube. So let's say the position z will be -1. So if we now save it, now it looks better, but now we have this gap. So where we're specifying the width, so let's also add some more value here. So let's say 0.2. So now it is spanning from starting position to ending position, like so. Okay, now just like the doll, let's create a class for our player, which will be just a circle. So let's create a class called player. So I'm going to say class player, and in the constructor function, so let's say constructor. So for the player, we want to create a sphere. So let's go to the documentation page and search for sphere. And here is the sphere geometry. So let's copy the codes, Ctrl C, and we can paste them here. And now instead of box geometry, we are using the sphere geometry. The sphere geometry takes the radius, the height segment, and width segment. And then we're creating the sphere with the geometry and material, like so. So now let's save it, go to our page, and let's try to create a player. So let's say const player. So we are going to say const player. If we now save it, we still can see the sphere. That is because the sphere is too big. So let's say the radius should be, let's try just 1. So here is our sphere. This is still too big. So let's say 0.4, or let's say 0.2, or let's say 0.3. And 0.3 should be good. For the color, let's try the white color. So let's say FFF. So now we have this white sphere. Now the position of the sphere should be in here. So let's say sphere.position.x. So sphere.position.x equals to the start position, like so. Now I want to create a function called run, and if we call the run function, the sphere should start moving. So we're going to create a function called run. Now before doing that, let's just say this dot player So this dot player equals to sphere, and we also want to know some info about the player. So we are going to say this dot info or this dot player info. This dot player info will be our object. So here we are again going to say, and we are going to say position x equals to start position. So basically where the sphere is currently. So currently the sphere is here. So we are saying position dot x equals to start position. We also want the velocity. So we are going to say velocity, and we're going to say the velocity should be 0. So velocity is basically speed. So if the velocity is 0, the sphere won't move. But if the velocity is 1, the sphere will move with a speed of 1. So we also want a function called update. And inside this function, first we are going to say this dot player info dot position x plus equals to this dot player info dot velocity. So keep increasing the player's position x, and then we're also going to say this dot player dot position x equals to this dot player dot position x, and we have to keep calling the update function. So in the animate function here, we are also going to say player dot update, like so. But now the sphere is not moving. So if we were to say the velocity is 0.01, now the sphere moves in that direction. So instead of adding, let's subtract. So minus equals to. And now as you can see, the sphere moves in that direction. But initially we want the velocity to be 0. And when we call the run function, the velocity should increase. So we can say, so in the run function we can say this dot player dot velocity equals to 0.03, like so. So if we save it, and then if open up the console and call the player.run. So if we were to say player.run, as you can see the sphere is moving, but we want to call the run function when we press our up arrow key. So let's do that. So we are going to use some event handling here. So we are going to say window.addEventListener. So we are going to say window.addEventListener, and we are going to listen for the key down event. And here for now let's just say alert e.key, like so. So now if I were to press some key, it alerts the key if we press. So if I were to press the up arrow key, it says up arrow. So here inside this function we want to check if we press the up arrow. So we are going to say if e.key equals to arrow up. If it is, then we want to call the player.run function. So we are going to say player.run. So now if I save it and now press the up arrow, as you can see the player starts moving. But when I release my finger from the up arrow, we want the player to stop running. So let's create a function called stop. So here is our class. So let's create a function called stop. So in this function we are going to say this dot player info dot velocity equals to 0. So we're setting the velocity to 0, so player will stop moving. So now we're also going to listen for the key up event. So copy this, and here we're listening for the key up. So the key down is when you press down an arrow, and key up is when you release that arrow. So inside here, instead of calling the run function, we're going to call the stop function, like so. So if we now save it and press our arrow key, it starts moving, and if you release our arrow key, it stops moving. Now to make this a little bit more interesting, what we can do is, instead of making the player stop all on a sudden, we can make it so that it takes some time for the player to stop. So we can do GSAP.2, we can say this.playerInfo, and we want to animate the velocity, and let's say the duration to be, for now let's say 1, like so. So if we press the arrow key, the ball starts moving, but if we release the arrow key, the ball moves for a while and then stops. So this will make the game even harder and more interesting. But instead of duration to be 1 is too long, let's say 0.1, so 100 millisecond. So it will take 100 milliseconds for the player to stop running, which will make the game a little bit more interesting. And let's delete this comment, we don't need it. Now I want to show a text here, so let's create a text. So you can create a text with Three.js as well, but I am going to use a regular HTML text. So I'm going to have a paragraph text with a class of text, and here we can say, for now let's just say loading, like so. So here is our text. So now you can see the canvas is pushed down, but we want the text to be on top of the canvas. So we are going to say our text to have a position of fixed. So let's say dot text to have a position of fixed. And let's say this should have a font size of, let's try 50 pixel, like so. And let's also say the font family to be Arial, like so. Let's say font weight will be bold, So font weight, bold, like so, and let's center it. So we can say left to 50%, and we're also going to say transform equals to translate x. So translate x, and it will be negative 50%. So now if we save this, as you can see, our text is in the center. So let's also say the top should be 10 pixels. So let's say top to be 10 pixel, like so. Also we want some shadow, so let's say text shadow. So let's say text dash shadow, and let's say 0 pixel from the x-axis, 2 pixel from the y-axis. The blur can be 5 pixel, and let's use some dark colors. So let's say RGBA000, and opacity can be, let's say, 0.3. So now the text is a little bit more visible. Okay, now I want to create a method in our doll class. So inside the doll, I'm going to create a method called start. So start. What this method will do is start the doll. So the doll will look backward for some time, then it will turn around and look forward for some time, then again do the same. So let's do that. So in the function, first thing we're going to do is say look backward. So let's say look backward. So this dot look backward, and now we want the doll to keep facing backward for some time. So we want to use some delay here, or we want the execution to be stopped for some time. So I'm going to create a function called delay. So function called delay. And what this function will do is take time as its argument and then return a promise that will resolve after the given time. So we can use this to stop execution of our codes for a while. So now we can make our start function asynchronous by saying async, and here we can say await delay, and let's say we want to delay for 1 second, and after 1 second we want this to look forward. So we're going to say this dot look forward, and then again do a delay. So we're again going to say await delay, and let's say 1000 second also, and then we're going to call the this.start function. So this.start. So as you can see, this is a recursive function. Okay, so now in the set timeout, so where is the set timeout? Instead of saying doll.look backward, we can say doll.start. So if we were to say doll.start, you'll see the doll looks backward for a second, then turns around, then looks forward for a second, like so. But instead of saying 1 second, we can use a random number. So this will make the game more hard and less predictable. So let's do that. So let's say the time should be math.random. So we're going to say math. So we're going to say math.random, and we're going to say 1000 second. This will give us a number between 0 to 1000, and if we were to add 1000 to it, now we'll get a number between 1000 to 2000. So the doll will look backward for 1 second to 2 seconds. So if we now save it, the doll looks backward for random amount of time. We can do the same for the look forward. So let's copy this, Control C, and paste it here. So this time let's say 750 to 700 and plus 750. So this will look forward for 750 millisecond to 1.5 second. Save. And now the doll looks at forward and backward for a random amount of time. So this is more hard and unpredictable for the player. So now our doll looks at forward and backward for a random amount of time, and we can press the arrow key to move our player. So now we are ready to implement the game logic. So first I'm going to create a function called init that will initialize the game. So let's create a function called init. This will also be an asynchronous function, so async. So here first what we'll do is delay. We'll use await delay, and we'll delay for, let's say, 500 millisecond, and after that the text should say starting in 3. After some time the text should say starting in 2, starting in 1, and then go. So first let's target our text. So our text had a class of text, so let's create that. So let's say const text equals to document.querySelector, and our text had a class of text, so .text text, like so. Now let's go to our init function, and inside the function let's say text.innerText equals to, we are going to say starting, so starting in 3, like so. So now let's call the init function. So init, save, and as you can see now it says starting in 3. So let me copy this 3 more times. So after 500 millisecond it will say starting in 2, and after that it will say starting in 1, and then it will say starting, and then it will say go. So the game will start. save it. As you can see, it says starting in 3, 2, 1, go. And after that, we are going to call a function called start game. So start game, and let's create that function. So function start game. So inside that function, we are going to call the doll.start. So let's delete this now, and we're going to call the doll.start here. So let's say doll.start. So now if we save it, as you can see, it says loading 3, 2, 1, and after that the doll starts moving around or turning around, whatever you want to say. Okay, now let's also show our progress bar. So the progress bar will just be a cube. So we're going to say let progress bar equals to, we're going to again call our cube function. So create cube. So create cube, and for the create cube, the width will be, let's say, 8, the height will be, let's say, 1. So height equals to, actually let's say 0.1, and the depth will be 1, like so. So if we save it, okay, we have some error. That is because we also have to pass a position x. So let's say position x should be 0. Save it. Okay, this should be d equals to 1, or depth equals to 1. Save it. So now we have this progress bar here. Okay, the width is too much. So let's say width should be 5. Here is our progress bar. We want the progress bar to be in the top. So let's say, so we're going to say progress bar dot position dot y equals to, let's try 3.35. If we save it, as you can see, here is our progress bar. Now we need to make it functional. So as time goes, the width of progress bar should decrease. So let's create another constant. So let's go to our variables here, and let's create a constant. So let's say const time limit. So that this will be the time limit for our game. So time underscore limit. Let's say the time limit should be 10 seconds. And now in the start function, where is the start function? Let's find it out. So here is our start function, so that we can again use the GSAP. So we can say GSAP.to, and we want to animate our progress bar. So let's say progress bar dot scale. So we're going to say dot scale. So we're going to set the scale x to 0 in the time limit, or in 10 seconds. So if we now save it, as you can see, the progress bar starts shrinking down. Also, we can specify easing function here. So we can say is equals to none. It will be linear, like so. So save it. And now the progress bar moves. Okay, one thing you will notice is the player can start moving even before the game is started. So like, as you can see, I can move before the game has started. So we don't want that. So let's create a variable called GameStat for game status. So in our variables here, we're going to say const GameStat for game status. So GameStat. So initially the GameStat will be loading. Copy this, and let's go to our event listeners here. So here, and inside the if, we are going to say if GameStat is not equals to started, then we don't want to do anything. So we're simply going to say return. So now if I press the arrow key, as you can see, the ball does not move. So inside the start function here, the start game, we can say GameStat equals to started. So GameStat equals to started. But I just realized that since we are reassigning to a constant, it will give us some error. So let's go back to our variables here. Instead of saying const, it will be let, like so. So now once the game is started, we can press the arrow key to move, like so. So now we pretty much have everything ready to go. Now we just have to implement the game logic. Okay, so now in the player class, where is that? So let's find it. Here is our player class. We're going to create another function called check. This will check if the winner has crossed the board or if the winner has lost. So inside the update function, we can call the check function. So let's say check this.check. And since in the animation loop we keep calling the update function, the check function will be also called again and again. So now what we want to do is check if the doll is facing forward and the velocity of our player is not equals to 0. That means the player was moving when the doll was looking forward. That means the player has lost. So let's try to do that. So first we need to create a variable. So let's create a variable called let is looking backward. So is looking backward. So by default it could be true. So let's say true. It should be is doll looking backward, like so. So once the doll looks backward, we want this to be true. Once the doll looks forward, we want this to be false. So let's see how we can do that. So let me copy this. Inside the doll class, we have this look forward and look backward button. Let me delete this. We don't need it. As you can see, it takes 450 milliseconds for the doll to look backward. So we can do a set timeout. So we can say set timeout, and we're gonna run this function after 450 milliseconds. And after 450 milliseconds, what we can do is say is looking backward equals to true. And let me copy this and let's paste it. So Control V. So here we want to say looking backward equals to false. Okay, but even if the doll rotates just a little bit, we should be able to move. So instead of saying 450, let's just say 150. So if the doll has rotated just a little bit, we are free to move, like so. Save. Now let's go to the player's check function. So in the check function, we're gonna say if player. So we're going to say this dot player info dot velocity. So velocity is greater than 0. And the doll is looking forward, so we're going to say if exclamation mark is doll looking backward. That means if the doll is looking forward, in that case we can for now let's just say alert, you lost. Okay, now let's try to play it. So as you can see, when we try to move, when the doll is looking forward, we lose. So it is working. And in the check function, we also want to check if the player has successfully crossed this line. So if the player's position X is greater than the ending position, that means the player has won. So let's say if player.position.x is less than ending position, then we'll say you won. So let's comment this out for now and let's try to move. And as you can see, it says you win after your position.x is here. So, and because we set the ball's x to 1, the ball have to cross a little more space than the starting angle. So instead of saying position.x is less than this, we can say position.x is less than this plus 0.4, like so. And let's try to move. So now as you can see, once we cross this line, it says you won. So now we can uncomment this. So Control/uncomment. Okay, let's try to play it. Okay, it looks like we have a little bit of error. Let's fix that. So in this function we have messed up. In the look backward function, this should say 150 and this one should say 450 instead, like so. So save it. Let's try to play it one more time. It says you lose. Let's play once more. And as you can see, if we successfully cross the track, it says you win. Now instead of alert, what we want to do is, as you can see, if I say okay, the alert will keep coming. That is because the check function is being called again and again. So if the player wins or lose, what we are going to do is if say game stat equals to over. And now let's go to the animation frame. Here is our animations frame. So we're going to say if game state equals to, so game stat equals to over, we're going to return. So we don't want this function to be called ever again, so like so. Okay, so let's save it. And now let's try to run it. So once you lose, it says alert 0, you lose, and now we can close it. And once you lose, you cannot move forward anymore. Okay, now let's make the text say you win if you win, and say lose if you lose. So let's do that. So let's go to our check function. Here we are going to say text.innerText equals to, so text.innerText equals to you lose, and here we can say text.innerText equals to you win. So let's try to run it. Okay, let's delete the alerts. We don't need the alerts anymore. So as you can see, if we try to move, it says you lose. So let's try to win now. And now it says you won. Another thing we have to tackle is, what if the player runs out of time? If he runs out of time, we want to say time over. So let's do that. So inside the start function, so let's go to the start function. Here we're also going to do a set timeout. So we're going to say set timeout, like so, and we're going to run the function after the time limit is over. So we're going to say time limit times 1000. That is because our time limit is 10, which is in second, but the set timeout takes time in millisecond. That is why we are multiplying it with 100. So after that we're going to say if the game stat is not equals to over, that means the player have run out of time but he couldn't clear this track. So we are going to say text.innerText equals to, let's say you ran out of time. So you ran out of time. Okay, now let's see what happens if we run out of time. As you can see, it says you ran out of time and we cannot move anymore, we can do anything. But if we refresh, we can play again. So let's try to play. Oops, we lost. Let's try to play one more time. We have lost again. Let's try one more time. This time I'm gonna win. Oh no, I have lost again. Let's try one last time. And there we have won the game. So now everything is working as intended. So now we have successfully created the red light green light game from Squid Game. I hope you enjoyed this video and you have created it yourself as well. Don't forget to like and subscribe, and I will see you next time.